Hi everyone, I am Lokesh Kumar Alla and this is Nikita Tala. Today we are presenting our cold chain IoT monitoring system, a real-time temperature and humidity monitoring pipeline built for pharmacy cold storage. The problem we are solving in critical is healthcare. Medicines like vaccines and insulin must be stored between 2 degrees to and 8 degrees centigrade at all times. If the temperature goes outside this range, the medication becomes unsafe. So, we monitor our system this 24 by 7 automatically. Let me walk you through our GitHub repository. Our project is called Cold Chain IoT. Inside, we have three main parts: the config folder, which has our config.yaml file storing all settings like MQTT broker details, InfluxDB connection, temperature thresholds, and device information. Then we have the SRC folder, which contains three Python files: processor.py, model.py, and dashboard.py. And finally, our ESP32 Arduino sketch called coldchain ESP32.ino. So now let me show you the hardware. We have an ESP32 microcontroller connected to a DHT22 temperature and humidity sensor on a breadboard. The DHT3222 is a real physical sensor. It reads actual room temperature and humidity. The ESP32 connects to a Wi-Fi and every 10 seconds it reads the sensor and sends the data to a JSON message over MQTT to our laptops. Now, let me walk you through the software pipeline we built. When the ESP32 sends data, it goes through four stages. Stage 1 is Mosquito, Stage 2 is processor.py, and Stage 3 is InfluxDB. So, Stage 1 Mosquito, we have an open source MQTT broker running on our laptop. It receives all messages from ESP32 on topic called fridge or sensor. The Stage 2 is processor.py. This Python script subscribes to MQTT topic, receives each JSON message, validates the data, enrich it by adding a process timestamp and device metadata, and then writes it to InfluxDB. We also build duplicate detection, so if the ESP32 sends the same message twice, we can skip it. So, stage 3 is InfluxDB, a time series database that stores all our sensor readings with timestamps. This is what allows us to query historical data and show trend over time. Now my teammate Nikita Tala will continue from here. Thank you.
Hi, I'm Nikita. So now let me walk you through the remaining part of the project and I'll show you the dashboard and the live
Chain
demo.
monitor. I'm into the dashboard. You can see over here total records and anomalies find and average temperature, and this is the anomaly rate. This is our real-time streamlit dashboard. So below this is our live temperature and the humidity chart showing the real readings, updating for every 10 seconds automatically. This next section is our machine learning output. We use an isolation forest algorithm for scikit-learn that learns what normal temperature looks like. And you can see here red dot and the green dot. Green dot is a normal readings. Red dots are anomalies. Now watch what happens if we introduce a real heat source near a physical DHT22 sensor. Let me start doing the doing it. So I'm holding the real matchstick near the sensor right now. Just we need to hold for 2 to 3 seconds, not more than that. So let's wait for the dashboard to refresh it, and then you will see the temperature spiked and a new red dot.
You can see here the green dots are normal temperature readings and the red dots are anomalies. And you can clearly see the spikes where heat was applied to the sensor. So this is our recent reading table showing the last 20 records with the timestamp temperature and the humidity and the anomaly flag. You can see the records 813 and the 817 showing rising temperature from 27 to 29 degrees, which are all flagged and as anomalies by our model.
So it also it time with the exact time stamps, as I said. Now it shows the temperature, it shows the humidity, and the anomaly column showing true at the spike readings. So the biggest challenge we faced for debugging a data pipeline or processor.py, which was missing the main block to start the MQTT loop. So it was silently exiting like a exiting without any error. So we also had an influx db401 unauthorized error because of our API token was not configured correctly. Once we fixed both issues, then it was fully pipeline worked perfectly. So what we learned from this IoT is not just about the hardware, the data pipeline, storage, and the machine learning are equally important. So our understanding of IoT completely changed. Now we now see it as a full end-to-end system, from physical sensor all the way to live visualization with anomaly detection. Thank you.